Hello students, my first video was on motion in 1, 2 and 3 dimensions, where I primarily concentrated on making the students of class 6 or 7 understand the preliminary concept. Today I am going to address the students of class 9 where the motion is represented graphically. After this, I really am welcoming queries from you and any topic of discussion that you want me to do. Let's proceed for it. As you can see, I have drawn a displacement time graph at the first point. What do you see here? Displacement is recorded along the y-axis and time is recorded along x-axis. What do we observe here? That time is changing, you see. The abscissa, I mean the x part is changing. But what about the y part? In the y part, there is no change, you see. If I am going to draw it like this, if this is time t second, t1 second, t2 second, t3 second, at all the times the object is at the same distance. Suppose this is 5 meters, this is 10 meters, okay. The object is at 10 meters distance from some reference point, even at 1 second, even at 2 second, even at 3 second. So what does that mean? That means that with the change of time, the distance of certain object from some reference point is not changing. It shows that the object is at rest. So what does it show? The object is at rest. For any object which has a changing distance with time, suppose at this moment it is at this distance, okay. After some time, at this time, the object is here, so the distance has changed, you see. Now we come to the second graph where displacement and time is plotted along y and x axis respectively. You see, with the change of time, the distance is also changing, you see. What does that mean? From some reference point, some object, suppose this is the object, okay, and from some reference point, this object has a change in distance and that change is uniform, you see. With the change, we get a straight line graph which is equally inclined, okay. If not equally inclined, it's not equally inclined, it is inclined to x and y axis. This suggests motion. What kind of motion? Uniform motion. So this is that displacement time graph. Come to this graph. In this graph, you see that with change, with variation in time, the displacement is not same. What do you see? With this, in this time, the displacement was this part, and when it was this, the displacement just changed by this amount. And when the object was here, the displacement just changed by a very minor amount. Can you see that? So what does that suggest? This also suggests motion, but it is not a uniform motion. It is a non-uniform motion. Now come to the next graph. It's a velocity time graph. You see, with the change of time, there is no change in velocity. It is the same constant velocity of that object, of any object, because time is changing. But along the y-axis, there is no change in ordinate. I mean to say abscissa will change, but ordinate is not changing. What does it suggest? It suggests that with the passage of time, the velocity of that object does not change. Hence, this suggests uniform velocity of that object. Okay? I feel it's clear to you. Come to the next graph. You see, the object has a change in velocity, you see, and it is increasing. And increasing in the same manner. That's why it's a straight line. Along the x-axis, when time is changing, velocity is also changing in the same manner. What does it suggest? It suggests acceleration of that object. You see, with the change in time, the velocity is changing. With the change in time, velocity is changing. And this change is uniform. So it's not only acceleration, it's uniform acceleration. So there is a change in velocity every moment. And it is a uniform change in velocity, and we call it uniform acceleration. The third graph, you see, it shows with the passage of time, the velocity falls. The velocity has a different value and it is less with the passage of time. When the time is this, the velocity is lesser than the previous time. When you select this time, the velocity is even lesser. Okay? So, there is a decrease in velocity with time. What does it suggest? It suggests uniform retardation. I feel it is clear to you. Now comes the fourth graph. Here you see, here at every point, whatever velocity is, it is not changing uniformly. Sometimes the change is high like this, and sometimes the change is not so much. Okay? Here we see a certain change. Here is also a certain change in velocity. Compared to these two changes in velocity, we find here with the same change in time, I mean to say with the same change in time interval, the change of velocity is smaller. So, this suggests a non-uniform velocity, but the acceleration is not uniform. You can see it's an increasing trend of velocity. That means velocity is increasing, but it is not uniform acceleration. It is non-uniform acceleration. Okay? So, this is acceleration, but non-uniform acceleration. I think it's clear to you. Now, one additional information which I think you all know. From this graph, we can calculate the change in velocity per unit change in time. I mean to say, we can calculate acceleration A from the slope of this curve. I shall make a different video for that, how to calculate acceleration from a velocity time graph, or how to calculate the velocity from a displacement time graph. The slope of a displacement time graph gives you velocity, and the slope of a velocity time graph gives you acceleration. I shall make a separate video for that with mathematical values. Thank you. Do write to me if you have any queries.